Hello, everyone. My name is Eleni Papanikolopoulou, and I am an iOS developer at Workable. Workable is an applicant tracking system that helps companies streamline their hiring process. And today I'm going to talk to you about RxSwift unit testing. So first, let me guide you through the agenda of today's presentation. In the beginning, we're going to go through some basic concepts of RxSwift. Then we're going to see how we can implement a very simple sign-in app by using RxSwift. And finally, we're going to explore the different ways in which we can unit test our app. So, RxSwift, I'm sure everyone in the room is familiar with the term. Either it's been in the latest developer conference you have attended to, or you have actually used it in your projects. So, RxSwift is basically the Swift implementation of Rx, and it uses the usual paradigms and patterns of reactive and functional programming. Some basic concepts are: first, we have observables. An observable is a sequence that emits elements asynchronously, and if you subscribe in that sequence, you will start receiving those sequence elements, aka events. But what is it, an event? So an event is that sequence element emitted in the observable sequence. So an event is basically an enumeration with three possible cases. A next case, which is the next element emitted in the sequence. Sorry for that. Here we are. An error case, which is emitted once the sequence fails with an error, and a completed case, which is emitted once the sequence is completed. Then we have observers. Observers listen for the events emitted. So an observer is basically a closure that is passed to an observable, and it is executed once the event is emitted. And we do that by using the subscribe operator. Then we have subjects. Subjects are basically a special kind of an observable that acts as an observer and an observable at the same time. This means that it can both emit and receive events. And in RxSwift, we have different kinds of subjects, such as a public subject, a behavior subject, a replay subject, and a variable. In our example, we're going to use a public subject and a replay subject. The basic difference is that once you subscribe on a public subject, you will start receiving the events emitted after the subscription happens. Whereas if you subscribe on a replay subject, you will also receive the events that have been emitted before the subscription happens. And this is called replaying of events. And a replay subject gets initialized with a buffer size, which corresponds to the number of the events it can replay. Then we have operators. Operators are used in order to transform, combine, or filter the events emitted. And in RxSwift, we have different kinds of operators, and there are too many. And one is impossible to know what each one of these does unless you have actually used it. But there is a very cool app that comes to the rescue. It's called Rx Marvels, and you can download it from the App Store. It's free, and it's pretty useful because it has a visual depiction along with a description of the operators, so it's really, really helpful. Then we have side effects. Side effects are basically callbacks that are registered and executed once certain events in the observable sequence take place. And we do that by using the do-on operator. So we have the do-on-next, the do-on-error, and do-on-completed. We call the do-on-next if we want to execute the callback after the event is emitted. We call it do-on-error if we want to execute the callback in the case of an error, and the do-on-completed if we want to execute the callback once the observable sequence is completed. Then we have schedulers. Schedulers are used in order to force operators to do their work on specific queues. And in RxSwift, we have different kinds of schedulers, and we very often use the main scheduler, especially when we want to do stuff in the UI, so we want to be on the main thread. Finally, we have disposebugs. We call the disposebugs once we want to cancel the subscription on an observable. So basically, an observable lives for as long as the disposebug to which it is attached to lives inside the app lifecycle. So now that we became a little bit wiser about RxSwift, we're ready to start implementing our app. It's a very simple sign-in form that has an email and the password, and also has validation for email and validation for the password. And once a correct email and password are typed, the sign-in button gets enabled. And once we click on the sign-in button, and sign-in request takes place. And if the sign-in request is successful, we get an alert with a success message. Or if it is unsuccessful, we get an alert with an error. So, what is the architecture that we're gonna use in order to implement our sign-in app? So it's basically the MVVM pattern. We have the view controller that has all the UI elements, and then the view model that has all the business logic. And the view controller exposes its events to the view model, and the view model does some stuff and generates the output, which exposes as observables to the view controller, to which the view controller subscribes in order to update its UI accordingly. So let's see how the view model looks like. The view model has some inputs and some outputs. So it gets an observable with a email typed by the user, an observable with a password typed by the user, and an observable with a button click, the sign-in button click. And these constitute the inputs of our view model. And it generates some outputs, such as an observable with whether the email typed by the user is correct or not, an observable of whether the password typed by the user is correct or not, and an observable of whether the sign-in button should be enabled or not, and an observable with the sign-in response. And these constitute the outputs of the view model. So what is the code that we need to write in order to implement our view model? In the view model class, we have the inputs that we described earlier. We have an observable of type string with email typed, an observable of type string with a password typed, and an observable of type void with the sign-in button click. And we also have the outputs that we described previously. An observable of type Boolean of whether the email that we just typed is valid or not. Same for the password. An observable of type Boolean of whether the sign-in button should be enabled or not. And an observable with a sign-in response. And the sign-in view model gets initialized with a sign-in API, which is of type sign-in API type. And this is a protocol, and we'll see afterwards how we can implement this protocol. And a dispose bug. So, in the configure method of the view model gets the inputs from the view controller. And we see how the view controller generates those inputs. And the view model tries to generate the outputs. And how does it do that? So, it creates that the email is valid, which is an observable of type Boolean. And it does that by taking the email text, which is an observable of type string, and converts this to an observable of type Boolean, which corresponds to whether the email that we just typed is correct or not according to a regex that we use. And it does that by using the map operator. And it does exactly the same for the password, which is also an observable of type Boolean. And now it creates the sign-in button enabled. And it does that by using the combined latest operator, which combines the events emitted by the two aforementioned observables, and returns a result only if both email and password are valid. And you can see here that we use this start with operator with an initial value false. This is because our sign-in screen first appears. We want the sign-in button to be disabled even though the user hasn't typed anything yet. So we want an initial event to disable the button. And then it creates the sign-in action. Now let's see this piece of code a little bit more thoroughly. You see here that we use three different operators: the combined latest operator, the unwrap operator, and the flat map latest operator. Now let's see what each one of these operators do. The combined latest operator, as we said earlier, it combines the events emitted from the input observables and generates another output by applying a function that we have specified inside the closure. The unwrap operator, which is part of the RxSwift extension, and thus which requires different import, it returns a sequence of non-optional elements. This means that it basically filters out the events with nil values. And then the flat map latest operator gets the latest events emitted by observables A and B and flattens the result to a single observable. So now that we explained the operators, we see here that we combine the events emitted by all the input observables, the email text, the email is valid, the password text, the password is valid, and the sign in button tab. We make the validation by returning an event only if both email and password are valid. Otherwise, we return an event with nil value and we unwrap it afterwards, which means that we filter out those events. And then we create the sign-in details. We pass it to the flatmap latest. It makes the sign-in request and returns the sign-in response as an observable. And we do all of these things by only using these lines of code. So this is what I'd like to call as Rx magic. Now let's see how the sign-in API is implemented. We have the sign-in API type protocol, which we will use afterwards in order to be able to mock our network requests in our tests. So the protocol has a method, the sign-in, which gets the sign-in details as an input parameter and returns an observable with a sign-in response. And the sign-in response is struct with a token. And the sign-in API, which conforms to the sign-in API type protocol, it has the same method signature, of course, the sign-in. And here we have assumed that we have created an HTTP client, that it's a wrapper and wraps our requests to observables. So this is how the sign-in API looks like. Now let's see our view controller. The view controller has outlets for all the UI elements that we saw earlier. And the view did load, we initialize our view model with a sign-in API and a dispose bug. And the view controller generates the inputs. And it does that by using this reactive extension .rx.text. And I have to say here that RxSwift provides this kind of reactive extensions for most UI elements, for text fields, buttons, switches, and so on. And we also filter the events that have strings that are empty. We don't want this kind of events. So we create this input and we pass this input to the configure of our view model. And we do the same for the password and for the sign-in button tab. And what we also have to do in the view did load is that we need to subscribe in the output observables of the view model. And we do that by using this bind operator, which is a special kind of subscription that also includes error handling. And here I have to say that both parts of the bind operator should be of the same type. Here the type is observable of type Boolean. So this is how we manage to show or hide the error label, the email error label, according to whether the email type is correct or not. So we subscribe to the rest of the inputs of the view model. And also we subscribe to the sign-in in order to make the sign-in request, take the response, and show an alert with a successful or a message or an error message. And this is all the code that we have to implement in the view controller in order to implement our sign-in app. So we are ready to start writing our unit tests. We saw earlier that this is the architecture that we used in order to implement our sign-in form. Now, what we have to do in order to write our unit test is that we need to fake the way the view controller feeds the events to the view model, and then get the output events from the observables and verify them. For our tests, we're going to use Quick and Nimble. Quick is a behavior-driven framework that is in which the tests are written as simple structures, and it uses Nimble as a mature framework. And with Quick and Nimble, its test its expectation is written as expect something to happen or expect something to not happen. And this is how a test class looks like with Quick and Nimble. In the before its closure, we have all the initialization code. And then inside the context, we specify a condition that we want to apply. And inside the it closure, we have the expectation or the assertion. But before we start writing our test, we need to decide what is it that we want to test. And what we want to test is basically the view model, because this is the class that has all the business logic. We could also test the bindings that take place in the view controller, but this probably at the secondary staging. So in order to mock our network layer, we will need to create a sign-in API fake that conforms to the sign-in API type protocol. And it has the same method signature, the sign-in. And it also has a Boolean value, which is a sign-in called, which gets a true value once we subscribe to the sign-in observable. And also has a sign-in return value, which is a public subject with a sign-in response, which we will use afterwards in order to be able to mock the return of the request from the server. So there are different ways in which we can unit test our app. And the basic differentiating factor is the way that we set the timeline of events. So the different ways are by using a public subject, by using RxBlocking, by using a test scheduler, and by using Marble syntax. And we're going to see how we can write the unit tests with all these ways and discuss their pros and cons. So let's start writing our unit test by using a public subject. In our test class, we have our subject under test, which is the sign-in view model. And we have a sign-in API, which is of type sign-in API fake and a dispose bug. And we have a public subject for each one of the input observables of the view model. So we have a public subject of type string for the email text, same for the password, and a public subject of type void for the sign button tab. And we also have properties for the output events of the view model, which we will use afterwards to verify the results. So in the before each, we initialize our sign-in API and our dispose bug. We initialize the sign-in view model with a sign-in API fake and a dispose bug. We initialize our public subjects. And we pass those public subjects in the configure method of the view model. And what we also have to do in the before is that we need to subscribe in each one of the output observables of the view model and store the values of the events emitted in the properties that we specified earlier. So we do that for each one of the output observables. So we're ready to start writing our sessions. In the beginning, we expect to have an initial event that the sign-in button should be disabled, which corresponds to the start with operator that we used earlier. And then we give a next event to the public subject to simulate that the user has typed an invalid email. And we expect to have an event emitted with a value false that the email that we just typed is invalid. And then we have a next event with an invalid password. And we expect to get an event emitted with a value that the password we just typed is not correct. And since both email and passwords typed are not correct, are invalid, the sign-in button should be disabled. And we continue on by giving next events as if to simulate that we have typed a correct email and password. And we expect to have events that the email and password we just typed is correct. And since both are correct, the sign-in button now should be enabled. And since the sign-in button is enabled, we have a next event to simulate that we click the sign-in button. And we expect that the sign-in request has taken place. And we give a next event with a fake sign-in response. And we expect to get an event with the sign-in response that we just gave. And we're done. This is how we have managed to write our unit tests for the view model by using a public subject. Now, let's see the pros and cons of this way. You see here how the test class looks like. There is a lot of nesting. So it's relatively easy to write and read. It doesn't require any special knowledge of the testing infrastructure of RxSwift. And we don't have to think the timeline of events right from the start and the expected events right from the start. We think about them as we write our test class, as we write our nested contexts. But as we saw, there's a lot of nesting. And we don't test when the events are emitted, only which events are emitted. And we'll see afterwards how we can test also when the events are emitted. Now let's try to write the same unit tests by using RxBlocking. Now RxBlocking is a different framework provided by RxSwift and thus requires a different import And what other RxBlocking does is that it blocks the current thread and waits for the observable sequence to complete. And by using the toBlocking operator, we convert a regular observable to a blocking observable. And by using the toArray operator, we get an array of the events emitted from the observable once the observable sequence is completed. Because if the observable sequence is not completed, we'll never manage to get the events emitted. And RxBlocking doesn't work with a published subject, and there is a relevant GitHub issue about it. And for this reason, we're going to use a replay subject. So in our test class, we initialize a replace subject for the input observables in order to replace the published subjects that we have had earlier, and with a random buffer size 10. And we do this for all of our input observables. And we pass those input observables to the configure method as before. And this is how an assertion looks like now by using RxBlocking. You can see here that we use try syntax because the toBlocking operator is throwable. So we get the first event emitted from the sign-in button enabled observable, and we validate the value. And this is how, here we use the toArray operator to get the events emitted in an array and validate them. So this is how our assertions look like now. You can see here that we have the additional uncompleted events because, as we said earlier, we will never get the results, the events emitted unless the observable sequence is completed. So let's see the pros and cons by using RxBlocking. It's again relatively easy to write and read. We just call toBlocking on an observable and we get the results of the observable. And again, we don't have to think the timeline of events and the expected events. We think about them along the way. But we have those additional completed events which doesn't correspond to real case scenario. And we can't use a published subject, so this is a restriction that we have. And again, we don't test when the events are emitted, only which events are emitted. And we cannot use RxBlocking for non-terminated sequences. And RxBlocking blocks the current thread, which means that our tests may maybe take a little bit longer. Now, let's write the same tests by using a test scheduler. A test scheduler is provided by RxTest, which is also a different framework and requires a different import. And with test scheduler, we simplify the testing of time-based events. And a test scheduler enables us to create a mock observables and mock observers. They are called a testable observable and testable observer. And it enables us to record those events and test them. And a test scheduler has a clock with a virtual time. And here I have to say that virtual time doesn't correspond to actual time. So 10 in test scheduler doesn't correspond to 10 seconds. A testable observable has the advantage of exposing an event's property which can take and validate it. So we initialize the test scheduler with a virtual time 0, and then we create the observer by using the scheduler, and then we subscribe the observable we want to test on that observer. So we will be able to listen for the events emitted from that observable. And then we can take the events emitted from the observer and validate the results. So we initialize an observer for each one of the output observables of the view model that we want to test, and it goes without saying that they should be of the same type. And we can schedule at virtual time 0 to subscribe the output observables of the view model to its corresponding observer. And now we can use the scheduler to schedule when we want our events to be emitted. So we schedule each one of the events we want to emit. And we should never forget to run this line of code, scheduler.start, because if we don't run this line of code, none of the above will happen. So this is how an assertion looks like by using the observer. We take the events property from the observer and validate the value of the event emitted. And these are the rest of the assertions. And the rest of them. But here we can take it a step further. We can have a testable observable in order to replace the publish subject and replay subject that we used earlier for the input observables. So we use the scheduler in order to create the testable observable. And you can see here that we also specify the virtual time that the event is emitted. And we pass this testable observable to the configure method of the view model. So we do this for each one of the input observables. But we can take it in a step even further, and we can specify an array of the expected events, like this. So you can see here that there's a correspondence in the time of the events emitted and the events that we verify. We have an initial event at virtual time 1 with an invalid email, and we verify that the same virtual time we get an event that the email that we just typed is incorrect. So this is how we have managed to test the time of events as well. So this is all the expected events, the array of all the expected events. And this is how our sessions look like now. You can see that the sessions have been simplified a lot. We verify an array of events from the observer against an array of expected events. Let's see the pros and cons of this way. You can see now that there is no nesting, and the before each closure has a lot of code. So there's no nesting, and the assertions have been simplified a lot, and it's relatively easy to read, and we also have extra flexibility to test when the events are emitted. But there is a lot of boilerplate initialization code in the before each, and we have to think the timeline of events right from the start in the before each, which can be simple for more simple flows, but it can be rather difficult, especially if the flows are more cumbersome. And we have to think also the expected events right from the start. Finally, let's write our test by using Marble syntax. Now, Marble syntax is a little bit peculiar. We have a dictionary in order to specify the events, whereas the key is the name of the event and the value is the value of the events emitted. And we use this syntax to specify the observable sequence. The horizontal dashes correspond to the virtual time, whereas the vertical dash corresponds to the fact that the observable sequence is completed. And this is how, by using this syntax, we can specify an observable. So we're going to have exactly the same properties as before. We're going to have testable observables for the input observables and observers to listen for the events and array of recorded events. But we're going to initialize them differently. We're going to use Marble syntax in order to initialize it. So with Marble syntax, as I said to you earlier, the key is the name of the event and the value is the value of the event emitted. And this is how we specify the observable. And then we create the observable by using the scheduler. And you can see here that we use these parse events and times, which is a part of the scheduler extension. So this is how we can specify the input observable now by using Marble syntax. So we do this for all of our input observables and for the output observables. Now, I know that this looks very strange, especially if you haven't used Marble syntax before. It looks like hieroglyphic. And the assertions are exactly the same as before. We get the array of the events from the observer and validate it against an array of the expected events. Let's see the pros and cons of this way. Again, there is no nesting, and we have also extra flexibility to test when the events are emitted. But it's really difficult to write and read. And we have to think again the timeline of events right from the start and the expected events right from the start. Now, I'm sure most of you are confused because it's a lot to take in. But if you want to take one thing home from this presentation is the following. If you want to write unit tests with RxSwift and MVVM, you just have to fix the events that are fed to the view model, and then get the output observables and verify the results that they emitted in the correct time. And if you understand this, you have really understood the basic concepts of RxSwift unit testing. So to sum up, there are different ways in which we can unit test a component, and each one has its pros and cons, but each one should select the one that suits your needs. So for more simpler flows, you may find yourself to use RxBlocking should be sufficient. Or if there are more complex flows, then you should use it as scheduler. Or at some point, you may combine two ways together. So maybe you will use it as scheduler along with RxBlocking together. So thank you. And this is the GitHub link that has all the code that I showed you. And I will be available for questions throughout the day. And you can also send me a direct question in Telegram. So thank you.
Thank you, Eleni.